Hi kids, we've already gone over the first example. We did that in class today, and of course number 1 was the same as an example, so let's go over number 2 here. Number 2 says we have a car. It's going 3 meters per second. It's 1,000 kilograms. We have another car. It's going negative 5 meters per second. It has 500 kilograms. I want to calculate the total momentum before they crash, the total momentum after they crash, and then I will have an unknown value, which is looks like the total speed of the combination of the two cars, and I can find that in step 3. So one step at a time. First, we know that this says it right here. The speed of car number 1 is 3 meters per second. The mass of car number, says A, we'll go with A, is 1,000 kilograms. And of course, from that, we know that the momentum is 1,000 kilograms times 3 meters per second. Last time I checked, that was 3,000 kilogram meters per second. This is the momentum of car A. Car B has a momentum of, well, let's see. Car B's speed is 0 meters per second. Its mass is 500 kilograms. And of course, its momentum is mass times velocity, which is 500 times 0, and we know that it's 0. The total momentum of the two cars as a system before the collision is that plus that. It's the total moment. The total is the car A plus car B, which of course is 3,000 kilogram meters per second plus 0. So my answer for the first one here is 3,000 oh gosh, I should have been over here. 3,000 kilogram meters per second goes right here. Part 2, step 2. Step 2 is to find, it says calculate the total momentum after the collision. Now I know we can't calculate it because we don't know the velocity, but we can set up an expression that we can use to solve for it. So now the two cars are smashed together and they have a new mass. Well, they have the same mass, the two masses combined. Mass of the car, the first car is 1,000, and the mass of the second car is 500. So our combined mass is 1,500 kilograms. That's the mass of the car. The speed of the car, we'll call it V total, is unknown, but we can still set up an expression. We'll call it P AB prime. Prime, of course, means after. P AB prime is just the mass of the combined two-car mashup times its speed. The car's speed we don't know. Okay, but we do know the mass is 1,500. And again, we do not know T. So this is now what we would put here, that PAV equals 1,500 VT. Again, that 3,000 should have been over there. Okay? Step 3 is easy. Take your total momentum from step 1 and set it equal to your total momentum from step 2, and then solve for the only thing you don't know. Our momentum in step 1 was 3,000 kilogram meters per second. Kilogram meters per second. Okay? Set it equal to our momentum after the collision, which is 1,500 kilograms times some number of meters per second, some speed. 3,000 equals 1,500 times unknown. Okay? And at this point, I know my algebra. I need to divide both sides by 1,500. So I divide this side by 1,500. kg. And I divide this side by 1,500 kg. And kilograms and kilograms cancels. Kilograms and kilograms cancels. 3,000 here on my calculator divided by 1,500 gives me 2. Then the meters per second remain. That is my speed of the car A-B combination after the collision.